Why distinguish and, or in compound algebra inequalities? Have you ever wondered why it matters whether we use and, or in compound algebra inequalities? Understanding this distinction is key to solving these problems accurately. Let's break it down in a simple way. A compound inequality consists of two separate inequalities connected by either and, or. When we use and, both inequalities must be true at the same time. Think of it as needing to meet two conditions simultaneously. For example, if one inequality says that x must be greater than 1, and the other states that x must be less than 5, then the solution is all x values that fall between 1 and 5. This means is greater than 1 and less than 5 at the same time. Now let's look at or. When we connect inequalities with or, we are saying that satisfying just one of the inequalities is enough. For instance, if one inequality requires to be less than 2 and the other requires to be greater than 6, then any x value that is either less than 2 or greater than 6 is part of the solution. So, you can have x values into separate ranges, below 2 or above 6. This difference is not just a matter of words. It affects how we solve and graph these inequalities. For and inequalities, we find where the solution intervals overlap. For or inequalities, we combine all values from each solution set. On a number line, and solutions show the overlapping area, while or solutions cover all regions from either inequality. Understanding this distinction helps prevent mistakes when interpreting solutions. If you confuse and with or, you might combine solution sets incorrectly, leading to wrong answers. In practical terms, inequalities connected by and often describe values within a specific range, like acceptable temperatures between two limits. On the other hand, those connected by or describe values outside certain ranges, like restrictions that exclude a middle interval. By clearly distinguishing between and, or, learners can confidently tackle compound inequalities, grasp the nature of the solution sets, and accurately representing them on graphs. This makes the topic much easier to handle and understand.